In this video, we're going to take a look at Intigriti's February challenge, which was created by GoatSniff. The description tells us that we need to read the admin's love letter and we can win some exclusive Valentines goodies. Just before we jump into the challenge, I also want to showcase the new Intigriti Gitbook. So I went back through all of the previous challenges that we've done and created a markdown page which has a link to the challenge, some useful resources, and then links to all of the community write-ups. In many cases, they also have a video if we created one, so that you can access that there as well. So going forward, we'll make sure to keep this up to date for all of the challenges that we make in future. Okay, with that out of the way, let's take a look at the challenge. So you can scroll down the page and there's an iframe of the challenge, but I prefer to open up the challenge page directly. Let's go and do that. And we'll come through to a login box where we can register a new user. I think my user's already going to be set up, which was cat. User already registered. Yeah, let's do another one then. I'll do cats. So on opening the page, we immediately see we can contact an admin, we can access some love letters, and we can log out. And there's a message here which says, to view a love letter, you'll always be prompted for your password, so nobody can see your letter except you. And we've also got a message here which says, we're so confident in security, even our own admin uses this page to store their love letters. So there's a bit of a hint. Let's go and have a look at the love letters page. And we go here, we can write a letter. So we've got 4 letters at the moment. Let's try and click on one of these. Enter some contents. I'm going to put something very original, which is my username, cats. And then whenever we try to view that message, we have to put in a password again, which is the password for our login. And then we can see the message. We also have the option to delete a letter as well. So the other functionality we want to check out is the contact admin page. There's actually a challenge info section, which tells us how the admin works. So we can download the source code and we're going to go and look at that in a minute. But basically, the admin will try to access our link. It'll first make sure that the domain is the same domain, or at least a subdomain of it. The already authenticated admin will click on the link. It'll get suspicious and then close the tab, and then it'll make sure they're still logged into their own account before they view the letters. And if they can't see the love letter they set, they'll simply re-add it and continue with their day. And our goal is to steal that letter. Let's also have a look in Burp Suite. We've just been through all of the endpoints that we can see based on the buttons on the website. So it's a good idea to have a look at the traffic and see what's actually going on there. And we'll immediately see that we've got a subdomain of api.challenge. So that looks interesting. We can also see we've got a JWT set. So perhaps there's a JWT related vulnerability, or perhaps not. And we probably want to go and check out some of these endpoints then. Maybe we could play around with them. Let us send one of these to the repeater. And one thing you'll actually notice here, if we put in like XYZ, so we try to fuzz for new API endpoints, it comes back with a message saying that it can't find that page, try debugging at, and then it gives us 2 endpoints which might be interesting to debug. So why don't we go and check them out? Let's take a copy of this. Let me paste this in here. We've got this set test letter. It says it's missing a message parameter. Okay, so let's say message equals cat and send again. And it has redirected us somewhere. Let's follow the redirection. And it has now taken us to a new page. The new page is read test letter with this random looking ID. And then the output is cat. So we have found an endpoint which allows us to write a message, which will then be reflected back in this link. And obviously this link could be shared with somebody, perhaps the admin. Why don't we go and see what this looks like in the browser as well? If I paste in that link that we just went to, the API challenge, and there we go. So it just redirects us to that page. Now, what about if we try and inject some HTML? So can we make the cat message be in bold? And we can. That's good. So the next thing we might want to try and do is see if we can actually trigger an alert here instead. Let's try and do image source equals X, which is not valid. So it's going to trigger an error. And that error is hopefully going to pop an alert. But it doesn't. We get this image, but if we go and view the source, we'll see that our onError script has been removed. So let's go and take a look at the source code. So open this up in VS Code. We don't have too much to look at. There's an app.js, a db.js, and then passport.js. And most of the functionality that we're interested in is in the app.js. And because there's like 600 lines of code in here, GoatSniff gave us a bit of help and basically said that he will add some comments to say that anything that's unrelated is not worth checking out. But that if you want to look at it for some 0 days or unintended solutions, that's also fine. So if we scroll down, we will see this challenge internals quite a lot. And there is a message here that says everything below the line until the next challenge or challenge internals. I think this means until the next comment is basically the way I read it. So feel free to read through this code and look for mistakes, but the intended solution, if we want to find the intended solution, we can basically skip through a lot of this code. Challenge internals all the way down, and then we see this saying everything above the line is just challenge internals. So it looks like this is going to be more interesting to us. We've got a store letter endpoint, an unset letter, a get letter data, read letter data, and some more internals. And then we've got the send admin URL, which is likely to be of interest, although we do already have a breakdown of how this is working, but maybe we want to see the actual code. And the most important stuff is towards the bottom, which is this function, set test letter. We know this is important because there is an error message saying that we should debug this endpoint and the endpoint below it. And as we review the source code, we'll see there's actually some comments in here which can kind of give us a bit of a hint. And what are the comments hinting? Well, we have one at the top that says rich text via HTML with DOMPurify for safety. And then one above the sanitize function that says we're testing rich text for the love letters, best to be safe. So the DOMPurify sanitize function, that's why the on error alert was stripped from our image, because it is sanitizing the message. And below that, we have this base64 encoding. So it sounds like the purpose of the encoding is to ensure that any rich text gets preserved in the love letter, maybe some emojis that can get lost in encoding and decoding. So it's base64 encoded, and then we're redirected to the letter ID. And whenever we get there, it's obviously going to need to base64 decode it, which you can see here, but notice that it is decoding it into ASCII format. Well, what's interesting here is the ASCII range is only 128 bytes, or 256 bytes for the extended, whereas UTF-8, Unicode, has millions of possibilities. I think like 1.1 million characters that can be used. So what happens if we provide some characters which aren't within that ASCII range? So if we provide a Unicode character that's well above 128, and then it gets encoded to base64, but then it gets decoded into ASCII, what's going to happen to that value? And this is where we have the vulnerability. We could call it Unicode normalization. And in this case, the buffer may process these characters in a strange way. So we'll have a look at this shortly. Interestingly, Goatsmith mentions that this vulnerability was found by mistake. So the second part of the challenge that we'll look at was already developed, and he was trying to add a little bit more around the challenge. And a suggestion that was made by GitHub's Copilot was to add this code, which would do the buffer.from and the buffer.to with the base64, and then from using the ASCII, which he just accidentally noticed that the message that he created as the love letter had a weird character in it, and that was because of this encoding and decoding. So he then adapted the challenge to make that an integral part of it. And if you didn't spot this, there was a hint which we gave out after 100 likes on Twitter, which was, are you sure 128 characters are enough to fully express love? So just before we formulate our attack plan, let's go and have a look at the admin functionality as well. And there are some comments in here which will explain what's happening as we go. So first, it's going to make sure that the URL provided is on the correct domain, being the challenge domain. Next, it's going to launch Puppeteer and then find the relevant user. It will create a new page, and then it will go to the login page and log in as itself. So there's a message here saying it simulates a user who's logged in already. So we'll do that first. And once it's logged in, then it will go to the admin URL. Then we have a message from the admin which says, I shouldn't have clicked that link. I'll open the site directly to check things are safe. So it will close the page that it's opened that we provided, and it will create a new page. It will go to the letters, and then it's going to simulate the admin checking the name. So it's basically making sure that it is logged into its own account, and it's going to do that by calling the /user endpoint and verifying the credentials. If it's not logged into its own account, you can see that it's going to say, that's not right, I'm going to close the browser and go about my day. If it finds that it is logged into its own account, it will then make a new request to get letter data, and this is making sure that the Intigriti community letter still exists. And if it doesn't still exist, it will create the new letter. So you can see here, it's making sure that it's currently set. And if it is, it'll just exit the page, it'll close down the browser. If not, it's going to write that message again. All right, that should be enough for us to formulate our attack plan. So part one, we're going to need to find some character that looks benign to DOMPurify, but will result in a dangerous character after decoding and allow us to trigger that XSS. But what do we do then? The cookie is HTTP only, so we're quite limited what we can do with JavaScript. We can't delete the cookie, for example. CSRF is not possible, as we need the password to read the notes. We could potentially trigger a redirect to log out and then log in as ourselves, but the admin also checks whether they're logged into their own account before they'll proceed with adding the new letter. So the admin is writing the note that we want to steal. How else could we steal the response without taking over the account? What if we just set the JWT in the cookie to our own so that when the note is written, it'll be saved to our account instead of theirs? Well, there's a few conditions here. As we mentioned previously, we can't delete the admin cookie. We could create a new one, but the oldest cookie will take precedence. Besides, even if we could do that, they check to make sure they're logged into their own account. And this is where path precedence comes in. So if we set a cookie with a specific path, like /store letter, then it will only apply there, and it'll take precedence over the older and less specific cookie. So basically, all other pages will use the old cookie, meaning that the login check will pass because that's not on the store letter endpoint, but the store letter endpoint will use our JWT. Finally, we also need to delete the fourth note with the ID of 3, since the admin won't try to write a new note if it's already set. Just before we go and demonstrate the DOMPurify bypass, I also want to highlight some amazing work from the community. This is a write-up from Misty's, and they created a diagram showing exactly how this Unicode normalization bug works. So we've got our user input, which is a UTF-8 string. It will be sanitized by DOMPurify and encoded to base 64. It'll then be stored, and later, when it's retrieved, it will be base 64 decoded, but the result will be decoded to ASCII instead of the UTF-8 encoding that it started with at the beginning. There are a lot of different characters that you can use to achieve this, and then also the character that you replace is up to you. There's probably a lot of different XSS payloads and things like that. One that I really liked came from Tofu Eel Roll, and just testing it out then, you can see that it comes back and it pops an alert for us. If we view the page source this time, we'll see that our on-error alert didn't get removed. And basically, why is that? Well, DOMPurify is going to see that cat emoji that we put in, and it's not going to see this tag. It's going to see the cat emoji, and it's going to read the rest of this, and then basically say, that's not vulnerable because we don't have a starting tag. But because the emoji is going to be base 64 encoded, and then it's going to be decoded as ASCII, this is the result, which basically, we've got a valid XSS payload here, and what comes before it doesn't matter. This is just part of the body. Let's experiment a little more. I'm going to go to CyberChef and we'll put in this emoji and just see what happens when we convert it. So paste this in here. Let us go and encode to ASCII, which will be under US ASCII 7-bit. And you can see it comes back with this equals angular bracket. Now, that's not exactly what we got here. I'm not too sure exactly why that is, but one thing that I did when I was just playing around with this as well, if we go to ASCII-to-hex.com, let us paste this in here as well and do convert, and you'll see that it creates this then. Now, what happens if we just simply change one of the values here? I'm going to change this to a D at the end, and we get a different cat emoji now, and if I go and paste this in now to this, you see we get equals equals. And if we check the ASCII table, we'll see that actually the last emoji was the equals angular brackets, and that translates to 60, 61. And whenever we incremented the emoji value by 1, we now get 61, 61, which is the double equals. Maybe we want to visualize this by playing around with some different characters, so you can just take the code from the existing app.js and we'll create a new one. And then if we try to run that, node app.js, this will visualize the output. So we can see that the cat emoji, when base 64 encoded and then decoded as an ASCII character, will result in these two characters. But there are over 1.1 million possibilities, so we could use a combination of some manual adjustments and a bit of ChatGPT to write a script here. You can see I'm looping through not too many of the values because there are 1.1 million total, but we basically loop through and want to see if the output string, so when it's decoded with ASCII, does it have any angular brackets in it? And it doesn't have to be angular brackets, so you can either replace the first one or the last one, but you can also replace some of the quotes as well. And I'm sure there's various ways of doing it. I don't really know all of the internals of DOMPurify, but let's give it a go anyway. I'm going to run this again, and you'll see that we get back quite a few results, and we can basically go and test these out. So If we wanted to replace the final angular bracket, this is what we could use. And obviously we can increase this as well. Let's put it up a little bit. So there's a lot of possibilities. So let's just take an example of one of them. This is the left angular bracket as well. And I'm going to go to Burp Suite. I'm going to send our original request to the repeater. So this is the one that stripped our script using DOMPurify. And if we follow the redirection, we'll see, yep, doesn't have our on error alert in it. So let's go back and let's replace this angular bracket at the start with our URL encoded value. We'll click send, follow the redirection, and look, there we get our alert. Anyway, we have verified our XSS vulnerability, so let's go and build our payload. Part 2 of our attack. As we said, we need to set a cookie with a specific path, and the path is store letter. And the idea being, whenever the admin goes to make sure they're logged into their own account, they will be, because they'll see their own JWT. The only path that they'll see our JWT will be store letter. And that's because the more specific path will take precedence over a looser path, even if the looser path is older. So let's test out the payload. I'm going to replace this. I've just done this with the syntax highlighting to make sure that we could see all of that. But let me take a copy of that. In fact, let us actually go and get our JWT as well. I'll go and take this from Burp Suite and paste this in here. And then we need to go and provide this with a URL. Actually, I'm also going to take a copy of that and put it down here so we can easily copy and paste in future. There we go. Let me get the syntax highlighting back. All right, looking good. So we'll paste this in here. Let's go and see if we can submit it. I'm going to go here and it looks like our image is showing, or it's attempting to load our image. We've got our test letter. Let's go and see how the admin responds to it. So there is actually an admin feedback section, which will appear as they visit the URL. There we go. We see a message. It says, I recognize the domain. I'll just click on this link and see what it is. And then it says, I shouldn't have clicked that link. I'm going to open up the site directly to check things are safe. But it's got this error saying, well, not an error, but it's got a message saying that the letter is already set. Secret is safe. I'll go about my day now. So it hasn't actually written the new letter. It hasn't rewritten the letter. So obviously, we're not going to expect to see it if we go and check our love letters. So the next thing that we needed to do was to add that delete function. I'm going to take a copy of this. Let's go back to our HTML. So I'm going to replace this one that we have here. And then let me just add our JWT right here. And then we'll do all of this, but using the cat emoji instead. And hopefully this will be enough. Let me take a copy of this. And we'll go to the browser. You could also do this in Burp Suite, but you just need to bear in mind that everything needs to be URL encoded accordingly. And let's go and try and send this to the admin. There we go. This time it says, I can see I'm missing a letter. Did I forget? Weird. I'll just set it now. And hopefully now if we go and look at our love letters, we'll see that actually we have a letter in the 4th slot. We'll try and view it. We need to input our password, and some people notice that you have this B character, which doesn't really make sense in the sentence. And I believe if we go and have a look at that now in the read letter data, we have, so there is the Unicode character here. So this is how GoatSniff originally discovered that there was a vulnerability in the Copilot code. So that was the intended solution, but a lot of people solve this challenge using a race condition. Earlier, we mentioned that it might be possible to force the admin to log out and then log in with our own account, just provide it with the credentials, and then it would write the note to our account. However, we know that the admin will check to make sure that it's logged in as the admin before it will proceed. Some people notice, though, including Misty's, whose writeup I'm looking at the moment, that you can actually defer the sign-in process. So in this example, they created 2 notes. You can see at the bottom, this is the note which will basically open a new tab. So although the admin is closing down the tab they open, it doesn't stop us from spawning new tabs, and the admin won't close those down. So the note will be sent to the admin. They'll open the other note, which you can see here, read test letter A, in a new tab. And that note will first unset the letter, and then it's going to set a timeout on the login. So there's going to be a 4-second wait before it attempts to log into our account. So this is a classic time of check, time of use vulnerability, where there is a time window, a race window as we'd say, in between the time that the admin will check that they're logged into their own account and the time that it'll actually write the letter. So that's basically what's happening here. Hopefully that makes sense. One small correction I want to make as well is the payload that we actually used with the cookie path precedence being set wasn't quite the intended solution. So we used a post request to delete the third letter, but actually the original intended solution set 2 cookies. The first would be a path of get letter data, and the second will be a path of store letter. And that basically means whenever it goes to check the get letter data to see whether the note has been set, it's actually checking our account rather than the admin's account. So then there's no need to delete that note. Anyway, this has been the February challenge by GoatSniff. Just to summarize then, we had an XSS vulnerability, but in order to trigger the XSS, we needed to bypass DOMPurify, and we did that through a Unicode normalization bug. After that, the intended solution was to use cookie manipulation, so we used the path precedence in order to play around with the path and make sure that some actions were done under our account, while others were done using the admin's account. There was an unintended solution, which was a race condition that we just looked at. And if you have any other interesting solutions, anything that we didn't cover in this video, or you didn't submit your write-up to us, you can always leave it on the Twitter post that we do at the end, or you can send us a DM and we'll add it to this Gitbook write-up. Anyway, I hope you enjoyed this video. If you have any questions or comments, as ever, leave them down below. Thanks.